Hello everyone. So let's say we have these two matrices here, matrix A and matrix B, and we want to go about finding the product A times B. Well, first, how do we define a matrix? We say that a matrix is defined by rows by columns. So matrix A has 1, 2, 3 rows and 2 columns. So A, we say, is a 3 by 2 matrix. And B has 2 rows and 2 columns, so B is a 2 by 2 matrix. So now if the columns of A match the rows of B, then we can actually do the multiplication. Then it's defined. So we just look at these inner numbers, and well, yeah, they match. They're both 2, right? And then what we're going to get, the AB is going to be the outer. It's going to be a 3 by 2 matrix. So B is going to be a 3 by 2. We can set this up as we're going to have 3 rows. So it's going to probably be 1, 2, 3 rows and then 2 columns. So something like that. We're going to have 3 rows and 2 columns. Okay. And then how do we find what the entries are? Well, if we just say that every entry, if we define it as the ij entry, well then the ij entry of this matrix is just going to be the dot product of the ith row of A with the jth column of B. What does that mean? Well, to do a dot product, you need vectors, right? Well, we can just let our column, we can say our rows of A are vectors and our columns of B are vectors. Then, okay, so then how does this work? Well, we know we're going to have a 3 by 2 matrix. So the first entry is going to be the first row and the first column. The ij just corresponds, the I is your row and the J is your column. Okay? So the first entry here, the 1, 1 entry, the first row, first column, is just the dot product of the first row of A with the first column of J. So what's the first row? So we just take 1, 2, and we dot that with 5, 1. So 1 times 5 plus 2 times 1. That's just 5 plus 2, that's 7. And then you can go any entry you want, really. I'll probably do my first row first. So then my second entry is going to be here. That's the first row, second column. So the first row, second column. Okay, the first row, second column is just the dot product of the first row of A with now the second column of B. So just 1, 2 dotted with 2, 7. So that's 1 times 2, 2 plus 2 times 7. So that's 2 plus 14, so 16. And then we just finish. We just go down here. And now we're in our second row. So our next entry is going to be our second row and our first column, right? This entry right here is our second row, first column. So it's the dot product of the second row of A with the first column of B. Okay, so that's 3 times 5, 15, plus 0 times 1. Well, that's 0, so that's 15. Okay, and then just keep on going. What's here? Now we're in our second row, second column. Our second row, second column. So second row of A dotted with the second column of B. So that's just 3 times 2, which is 6, plus 0 times 7, 0. So that's just 6. And then our last row, now we're in our third row, first column. So third row, first column, 4 times 5 plus 5 times 1. So that's 20 plus 5, so that's 25. Okay, and then our last entry is our third row, second column. So it's the third row dot product with the third row of A with the second column of B. So that's 4 times 2, 8, plus 5 times 7. So that's 8 plus 35. What is that? That's 35 plus 8. 35 plus 10 is 45, but it's plus 8, so 43, right? My arithmetic is not the greatest, but I believe that's right. So there's AB. Now we can say, okay, so that was A times B. Well, could we do, is that the same thing as B times A? Well, A times B is almost never equal to A times B. But in this case, what would it be? Well, matrix B is a 2 by 2, right? And matrix A is a 3 by 2. Well, the columns, right? The columns of B don't match the rows of A. These inner numbers don't match up, so BA doesn't exist. You cannot multiply matrix B times A. But matrix A times B, that's pretty simple, and we got AB right here. So there we go. I hope it made a little sense, and I'll see you guys really soon. Be sure to give me a like and subscribe, and I hope to see you guys real soon. All right, bye-bye.